Okay, I put up some summary information here to start this video on confidence intervals. So this is the formula we are going to use then for determining a confidence interval about the population mean in a situation where the population standard deviation is known. That's what this sigma is a population standard deviation. Z relates to our confidence level, and it's different depending on our different confidence level. Here's a table I pulled off the internet that shows these calculated. You can go to your Z table and you can look in the body of your Z table for the proper areas and determine what your Z and double check these Z's. You don't have to double check them, they're correct, but you can help confirm what these Z's are so you know where they come from. But you don't have to calculate these anymore. You can just pull them directly off of a table like this. So for example, if I had a confidence interval, a 92% confidence interval, my Z would be 1.75. That's what would go in for Z alpha over 2. And remember, alpha was the area outside our confidence interval area. So alpha in the case of a 70% confidence interval would be 30%, and then alpha over 2 would be half of that, would be 15% on either side of the rat tails. Okay, we could also set our formula up in this form. So that's let's see if I can page down. Yeah, okay. So that's a summary of what we've done in the past up to this point. But suppose now, so we're going to take this another step further. Let's say suppose we want to know the size of our sample. To ensure an accurate measurement. Well, to handle this, we can start with our margin of error. So let's call that E. So we'll start with our margin of error, and you can see the sample size is captured down here in the denominator, and it's also under a radical sign. We can isolate now this, use algebra and isolate, or we can solve for this value if we're given what our margin of error is. So let me just quickly do that. So if I multiply both sides by square root of n and divide both sides by e, I get square root of n on this side. E over e is 1, so that's going to divide out. And I get z alpha over 2 times sigma divided by e. So then I just take the square root of both sides and I end up with n equals z alpha over 2 sigma over e squared. So we can simply make that calculation in a situation where we're interested maybe in calculating a size of our sample that we need to take, given that we don't want the margin of error to be over a certain size. So let me do an example of that. I'm going to pause this and write the question. Okay, so my problem is a scientist wants to estimate the average river depth. He wants to be 99% confident that he is accurate to 2 feet. Assume that sigma equals 4.33 feet. So we can begin with pulling down some values. Well, what we probably want to do is we want to write down our formula right here. And what I'm going to do is I'm just going to copy it, the wonders, and paste it down here for you again, so you don't have to scroll up. So here's our formula. So some of the statistics and parameters we need, I'll write over here. So alpha equals, we have E equals, sigma's in the formula. So those are our 3 values in the formula. So go ahead and try to pick those out. Okay, so let me begin. Alpha is 0.01 because we got a 99% confidence interval. That means the area on either side is alpha, 0.01. 1 minus 0.99 equals 0.01. So alpha over 2 equals 0.005. We're talking about a 99% confidence interval. Now E, well, we'll come back to E. Sigma. Sigma's easy. Sigma's given. That's the population, 4.33 feet. Now you might be asking yourself, how the heck would they know that? And that's a good question. That's a very good question. And typically we don't know that. But at this point in our statistics knowledge, we have to know that in order to use the equation. We'll have a different equation in the future. But at this point, we need to know what the population standard deviation is, so it just has to be given. So what is E? Well, E is our error. So really, the error here, he wants to be accurate to plus or minus 2 feet. So our error is 2 feet. Okay, so now it's just a matter of plugging things in. Z, alpha over 2, Z for 0.005, Z of 99% confidence interval. I can just come up here. I see that that is 2.58. I don't have to go to the tables and figure that out. You could if you want to, but you can take that shortcut. 2.58 times sigma 4.33 over 2. We could put divided by 2 anywhere in here since these are all multiplied together, and this whole thing squared. You go and you do that multiplication, and you end up with n equals 31.2. So n equals 31.2. So the scientist has to make 31.2 readings, has to take 31.2 readings if he wants to be 99% confident that his average value he takes is correct. Now, you really can't take 31.2 readings. So if you were going to advise this scientist, you would probably tell him to take 32 readings. And then he would be sure that he would at least have a 99% confidence in his results. Okay, that's all I'm going to do for this video.